Hey there, welcome to the internet. I'm debuting a new camera angle today and a better camera. I realized I can record with my phone, which is so much better than my webcam, which is very shitty. But let's now get to shaping sounds. We looked at modulation, and before that, we looked at how to make sounds. And now we're going to get into like shaping the sounds and filtering frequencies. And after that, it's just about building synthesizers. So, shaping sounds can kind of look like this in a DAW. It gives a sense of dynamics to the sound because when an instrument is played, it's not just a sine wave that keeps constantly playing for like 1 second or like 1 minute, right? You need to like start somewhere. So, with a piano, you like press the key and it takes some time for it to reach like peak volume. And if I'm playing the flute, I need to start blowing and then it takes a while for me to get to a point where the notes slowly get to the maximum amplitude and then it stays somewhere. And as I move to the other note or stop playing, it also slowly tapers down. It gives a sense of dynamics to the sound, which without it, the sine wave that we made before, the modulation that we made before, kind of sounds very boring, right? In a more concrete way, we can look at it in the terms of piano. Basically, so when you press the key, the time it takes to reach the maximum amplitude is the attack, and then the time it takes to reach like the amplitude that it's going to remain in is like the decay, and then it's going to remain in that amplitude for however long you keep pressing the key. And once you release the key, it takes some time to just fall down to zero amplitude. So that's what we call release. And basically, this ADSR makes the envelope, which we can set different parameters to, and that will create different shapes out of our waveforms. And this is pretty easy to do with Python actually, because if we have the numpy array, we just need to like add a mask of sorts of the shape and then change the parameters of the mask and just multiply it with the waveform, and basically we have envelopes locked and loaded to go. But this is like a very simple envelope because we are like linearly increasing up and then linearly coming down. We could also do it exponentially. We could have different ways of playing around with the dynamics of the sound, and that's going to give us like very, very cool and interesting results. And of course, as always, we're going to start with our sine wave. And I mean, of course, we have our sine wave right here. Let's play it. Cool. And we have our array here, which is just an array made up of sine waves, to which we need to add our mask. And we're going to add the mask of attack. So we know that we need to attack for like 0.4 seconds, so it's going to take like zero point 0.4 seconds to reach the maximum amplitude. So now to convert the seconds into time, I mean the seconds is time, to convert the number of samples, we need to just multiply it with sample rate like we did before to actually like create these waveforms. And then we know that for the duration of the attack samples, we just need to linearly ramp up to like 1. And we already have the first part of our envelope, and we kind of do the same thing with decay, where we just pick the number of samples we need, how many samples till like it starts decaying or it gets to the amplitude where it remains at the sustain level. So sustain level is like the amplitude level that we're going to remain in. So this could also be 1, which means there is no decay and it just stays at like 1 amplitude. But I mean, here I'm setting it to like 0.6, so our note is going to sustain at 0.6 for however long it's playing. Pretty easy, we have it. And then now, since we know our attack sustain, and we can just set our release, so which is 0.4 seconds. So what we do is we just see how much duration is remaining, and then just say 0.4 seconds before that duration we need to start like tapering off. And that's exactly what we do. We figure out when the release sample should start, and then we just like set our envelope. It looks like this. So we have created our shape. Pretty cool. And this is kind of how release looks like, because now it's not kind of tapered. We just need to just add the tapering. Nice. So now that we have all of this, we can actually add all of this together. So just create an envelope class, see how much we need to have our attack, decay, sustain, and release levels to be, and then we just do the same thing. Take the envelope, calculate the number of samples, we apply the attack, we apply the decay, we apply the release, and then we also set the sustain. And once we do that, we can just like have our envelope locked and loaded, ready to go. So now we have amplitude of 0.5 and 400 as our frequency. So we have created this waveform. Let's hear it. Right, and now we're going to set our attack, decay, sustain, and release. This should work, right? It does not. There is an error. Why is that? It's because I'm attacking for 2 seconds and my audio is 2 seconds, so it cannot really attack for the duration of the entire audio. So there needs to be some kind of condition here that's important. So that condition can be written here. So I can just say if the attack samples plus my decay samples plus my release samples, which means the total number of samples that I'm adding masks to is like greater than the length of my actual waveform, which means this envelope is not possible. So we just need to raise an exception saying, I don't know, what do you want to say? You cannot do this, man. So now if someone tries to do this, we return a good error. It's not a broadcast error that no one can understand. But I can also now decrease the value of the attack and it's going to do it, because now it adds up to the duration of the original wave, and this is how it sounds like. Right, like you can see that the wave now slowly gets to peak amplitude and then sustains and then also releases, which adds this really interesting dynamics that does not exist for this original really boring sine wave that just constantly sounds monotonous, right? And we can do pretty interesting shaping with the sine waves. So this is how it looks like. Right, we have just created this like shaped waveform, and we can actually create like pretty interesting shapes by just playing around with our attack. So let's say I don't want attack and I don't want decay, then this would look like this, because now the waveform has no attack and no decay. So basically we can just play around with these values and create interesting dynamics out of our waveform, which is pretty fun, which is why I have left these cells empty. And now, since we talked about exponentially increasing the curve, because here we are actually linearly going, so we can just see that it just like tapers in a straight line, but it doesn't have to be a straight line, right? So I have added this exponential shape of sorts. Oops, I did not run the cell. Yeah, so now we can have some dynamics. So here it looks like the original one because my attack shape is like 0, but I can give it a bit more shape. So now it looks a bit more exponential, so I can make it more, and it's now a curve, right? So it does not really have to increase or decrease linearly. We can do pretty interesting things. And this is something I like to play around to make interesting sounds with my waveforms. And there are also like other envelopes which are available in different instruments where we can have some sort of a hold before the decay starts. So it becomes like a HDSR and not really like ADSR anymore. And we can also add as much as we want to our envelope and make like very interesting shapes. It doesn't really have to fall in this paradigm. We can do arbitrary wave shaping of sorts to make like very cool sounds, and all of this becomes very easy to do in Python because as we saw, we just need to create like a masking function, and we just need to create a masking function and just apply that masking function to the waveform, and we have our envelopes locked and loaded and ready. And this is pretty cool. So we can create like very interesting envelopes, and we can give them random names. It can also be like delay, attack, hold, and then followed by decay, sustain, and then release. So we can have a bunch of things that modern synthesizers do, add them to our simple envelope class, extend it, and make pretty interesting shapes. So now that we know how to shape our waveforms, we're going to get to doing this with the frequency, which is filtering. So looking forward to that, and I hope I can maintain the same video quality with my phone, which I kind of like. So yeah, see you next time. Bye.